Okay, Assalamualaikum dan salam sejahtera. Today, we from Group 9 want to present about derivative. Okay, the first of my group is Bargavi Vijayan. Second, Muaz Adlan bin Musleh. Third, Muhammad Fazlinuddin bin Azman. Fourth, Nurina Syafiqah binti Zurita. And last, Lily Hani binti Mat Konan. Okay, next, I want pass to next presenter.
Okay, I'm going to explain about what is derivative. Derivative of a function of a real variable measures the sensitivity to change of a quantity, a function or dependent variable which is determined by another quantity, the independent variable. For example, derivative of the position of a moving object with respect to time is the object's velocity. This measures how quickly the position of the object changes when the time is advanced. I will pass to next presenter.
Okay, I will present about what is differentiation. The process of finding a derivative is called differentiation. The result process is called anti-differentiation. Fundamental theorem of calculus states that anti-differentiation is the same as integration. Derivative tell a slope of function at any point. I will pass to the next presenter.
Okay, thank you, Norina. I will continue the next part, that is real life application. The first is case study 1. The question is water is poured into a conical container at rate of 10 cm cube per second. The cone points directly down, which has a height of 30 cm and radius of 10 cm. How fast is the water level rising when the water is 4 cm deep? Okay, next slide is diagram of the question. Okay, next I will explain about the analysis. The first step to complete this case study is that we have identified which initial velocity is 10 cm cube per second. In addition, the height of the cone has also been stated in the question, which is 30 cm and the radius is 10 cm. Next, to get the ratio between radius and height, we need to divide between the radius per height. The given radius is 10 cm and divide by the height of the cone, which is 30 cm. Therefore, we have been able to know that when simplified, the question for radius refer to radius equal to height per 3. Then, to find the volume of the cone, we use the existing formula for the cone, which is V equal 1 over 3 pi r power of 2h. When all value are entered, the volume obtained is 1 over 27 pi h power of 3. The next step, we need to find the equation for dv over dt. When dv over dt has been found, then you can find the equation for dh over dt by entering the dv over dt value that has been obtained before. Finally, to find the water level that increases when the water is at depth of 4 cm, which is dH over dt, we need to enter all the information into the dH over dt equation and will produce the answer. Next, for calculation, I will pass to my friend Muaz.
Okay, thank you, Muhammad Fazlinuddin. Okay, I will continue for the calculation section. Okay, first, dv over dt has been given in the question, which is equal to 10. We need to find the dh over dt, which is the rate of height in the cone. Okay, so we can see that ratio between radius and height we can separately do actually somehow exactly write the calculation given. So as we can get, R equal to H over 3. Then we need to find the volume of the cone, which is we use the cone formula 1 over 3 pi R square. Okay, so we substitute the radius and we get the exact value of the cone, which is 1 over 27 pi H. Okay, so we can continue to the derivative section. Okay, so the dv over dt has been given, right? Okay, so we derive the v, which is we can get the current equation 3 over 27 pi h square dh multiplied by dh over dt. So we just substitute or move around the subject to be dh over dt. So we can find dh over dt equal to 45 over 8 pi cm per second. Okay, I will pass to the next presenter.
Okay, this is for
Okay, thank you, Muaz. I will continue the case study 2. Okay. The question is determine the maximum area of rectangular window with semicircular at both sides and shows in diagram below if the perimeter of the window is 30 feet. Okay, next. That is a diagram of the question. Okay, I will continue analysis part. Okay. The first step to completing this case study is to find out what shape is used on the window. Once identified, there are two shapes found on window, namely semicircular and rectangular. Besides that, we also know where the perimeter for both sides is 30 feet. After that, we need to know the perimeter of the entire window and its length. After obtaining the perimeter of the entire window and its length, by using the formula of the area, the entire figure, which is area equal to pi r plus 2rl, and will produce the answer for the area of the entire window. Next, by using the formula dA over dr, we will obtain the radius value, which is 15 over pi. In addition, by using the formula, we will know where negative 2 pi is smaller than 0. Finally, the maximum value for the entire window is obtained by entering all the information obtained into the formula. Okay, for the calculation, I will pass to my friend Muaz.
Okay, thank you, Fazli. Okay, so for the calculation, okay, based on the given information, we need to find L, which is the given information perimeter equal to 30. So we just, okay, we can find L by using the information given. So L equal to 15 minus pi r. Then we need to find the area of the rectangular window. Okay, so the area equal to pi r square plus 2rl. So we need to substitute the L with the L we find earlier, and we can see that the area we actually found is 30r, which is 30 radius minus pi r square. So we need to derive the area to get the next step. So we derive the area dA over dr equal to 30 minus 2 pi r. Okay, so dA over dr equal to 0. We need to x cubed equal to 0. Then we can get the r equal to 15 over pi. So when we have find the r, we need to derive again the equation d d square a over dr square equal to, as we derive with respect to r, area respect to r. So when function is decreasing, the turning point is maximum, which is the negative 2 pi is less than 0. So we need to substitute all the information that we have found into the area equation. So we can find the area equal to 225 over pi feet square. So I will pass to the next presenter.
Okay, this is for conclusion. Derivatives are constantly used in everyday life to help measure how much something is changing. They are used by the government in population censuses, various types of science, and even in economics. Knowing how to use derivatives, when to use them, and how to apply them in everyday life can be a crucial part of any profession. So learning early is always a good thing. Okay, that's all from my team. Thank you.